Hey guys, Mr. Jenkins back with the third lesson of Chapter 5. We'll probably do some sort of review after this lesson because there was quite a bit in the first 3 lessons. So 5.3 is all about solving polynomial equations, which we've already done some because we've solved quadratic equations, okay? So that is basically your learning target, is to be able to solve polynomial equations, which includes quadratics and higher degree equations. All right, so we're going to be using factoring a lot today. We might look at the graphing calculator and stuff a little bit, but just kind of a key thing here is that the expression x minus a is a factor of the polynomial if and only if the value of a is a 0 related to the function. Okay, so we want those linear factors where we can use the 0 product property, which means basically we just set x minus a equal to 0, and then we go from there. There's a nice review of just the techniques of factoring. It's got your little shortcuts there and everything. So all of this is review from last chapter. So I'm not going to talk too much about it. It'll be covered in our examples. This is new, all right? The sum or difference of cubes. So this is new, and we will do, I'll probably do one and leave the other one for you. So a couple examples. See, we have a sum of 2 cubes, x cubed plus 64, and then a difference of 2 cubes. Okay, and you look at these formulas, they're not super easy. A plus b times a squared minus ab plus b squared, and a minus b times a squared plus ab plus b squared. You see there are a lot of similarities, right? The only difference between these two formulas is when it's a sum of 2 cubes, the plus sign comes first and then the minus sign. When it's a difference of 2 cubes, the minus sign and then the plus sign. Besides that, everything is the same. This is one of those formulas, though, you're not going to memorize without practicing it. Okay, so let me do one of these examples and then I'll leave the other one for you. All right, so let's look at this one. First, you got to recognize that it's a sum of cubes, so that we're going to be using this formula. Okay, and from there we'll just figure out what a is and what b is. So a is the cube root of the first term, b is the cube root of the second term. So a is equal to the cube root of x cubed. That would just be x. All right, and then b is going to be equal to the cube root of 64, which you can get by guessing checking. There's also a cube root button on your calculator. Let me try to remember where it is. I think it's under math, maybe. Yeah, so cube roots right there, option 4, and then 64. Whoops, that's not what I wanted. I was in the wrong space, sorry. Let's go back out here and try that. So that was under math. Option 4, cube root of 64 is 4, right? So that just means 4 times 4 times 4 is equal to 64. So it might be easier to just kind of come up with this with guess and check. All right, so A is x, B is 4, and then we just sub into this formula right here. So first binomial is going to be x plus 4. And then our trinomial is going to be a squared, so x squared, minus a times b. So minus 4 times x, plus b squared, so plus 4 squared would be 16. Okay, so then you want to always check. Sometimes this may be able to be factored, but just think about it. What can we multiply to be 16 and add to be -4? So we couldn't make like 16 and 1 work. We couldn't make 8 and 2 work because those are 4 apart, and those are really your only combinations. So that can't be factored. So at that point, you would be finished. Okay, I'll leave this difference of cubes for you to try, and I do suggest you try it. All right, so now we're just going to go through some examples. I think I'm going to do the first 5 examples here, and the directions say what are the real or imaginary solutions of each polynomial equation. Okay, so one important note before we start is we can tell the number of solutions by the degree of the expression. Okay, so like a second degree expression will have 2 solutions. This is going to end up being a 4th degree because if I multiplied those, I'd have x to the 4th. So 4 solutions. 4 solutions for number 3. 3 solutions for number 4. So that's a key kind of basic idea. All right, so looking at number 1, we will try to factor here and then use the 0 product property. That's generally going to be our method. All right, so what's going to, well, first of all, I noticed that a is equal to 1. So I know it's going to factor to x plus or minus something times x plus or minus something. Right, we're going to make it easy. Then we're thinking, all right, what multiplies to be 4 adds to be -5. That would be -4 and -1. All right, so those are, that will give me my linear factors. X minus 4 is one of them, x minus 1 is the other. And like we say, we just use the 0 product property. So x minus 4 equals 0 tells me that x equals 4. X minus 1 equals 0 tells me that x equals 1. Okay, and we can always verify by punching it into the graphing calculator. If we want to just see it real quick, I'll do that. So x squared minus 5x plus 4. And we're going to see where is the value of the function equal to 0, aka where are the x-intercepts. And sorry, my window's weird, but we can see it's where x equals 1 and where x equals 4, just like we said. Okay. Other things you could do are, plug in 4 there, plug in 4 there, see if it works. Plug in 1, see if it works. Okay. Looking at number 2. Make that look more normal for the rest of the video. All right, looking at number 2. Kind of a weird kind of deal here. We have a quadratic binomial times a quadratic binomial. So what we're going to do is basically, you can think of this a couple different ways. If we just use the 0 product property here, you could think of it as x squared minus 1 equals 0, and then solve using square roots. So you'd have x squared equals 1 and x equals plus or minus the square root of 1. Or, you could factor this out because this is a difference of squares. So this factors out to a plus b times a minus b. So x plus 1 times x minus 1. And then you have your linear factors that give you the same solutions as what we just said. X equals -1, x equals +1. All right, so those are 2 of my 4. And then, so this other factor, x squared plus 4. So again, think about the 0 product property there. If I tried to solve the equation x squared plus 4 equals 0, then that's not I'll look at that, that's not a difference of squares. Okay, that's a sum of squares. So when I go to solve this using square roots, I would get x squared equals -4, right? And so x equals plus or minus the square root of, -4 is what that should say, -4. All right, so if we simplify that, that's going to be an imaginary number, right? So that would be equal to 2i. So my other two solutions from here, x equals plus or minus 2i. Okay, so let's see what that looks like on the graph. So the original equation was parentheses x squared minus 1, close, open parentheses, x squared plus 4, close, and then let's see what this looks like on the graph. All right, so we see our -1 and our +1, which we have there, right? But that's all we see. So this is where that knowledge would come into play, and you would say, well, this is a 4th degree, because if I take x squared times x squared, that's x to the 4th, right? So I know I need two imaginary solutions, right? So a lot kind of goes into this. Just looking at the graph, all you would get is your two real solutions. Then you need to use some algebra, factoring, or in this case, we use square roots to come up with your two imaginary solutions. You could really even use the quadratic formula, okay, where you would set b equal to 0. But anyways, the big thing is, you know, it's a 4th degree polynomial, so you should have 4 solutions. All right, looking at number 3, kind of another one where we should have 4 solutions. So that says x to the 4 minus 13x to the 2 minus 48 equals 0. Okay, so we are going to use factoring by grouping here. All right, so so our thought process, what's gonna multiply to be -48 and add to be -13, all right? And that's gonna be -16 and +3, -16 and +3. So we'll have x to the 4 minus 16x squared plus 3x squared minus 48 equals 0. Okay, then we factor by grouping. And again, I only did that. I know our lead coefficient is 1, but we have that x to the 4th. So that's what makes this one a little bit weird. So I can factor out of these two an x squared. Leave me with that. I can factor out of these two 3. And that would leave me with x squared minus 16. All right, so then we can see that my final answer, or getting toward my final answer, would be x squared plus 3 times x squared minus 16 equals 0. And I'm out of space. I could keep factoring here because that's a difference of 2 squares. It'd be x plus 4 times x minus 4. But I'm going to think in terms of square roots. All right, kind of use the 0 product property. Okay, so this one, first factor, I know it's not a linear factor, but we could still use the 0 product property. If we have x squared plus 3 equals 0, that would give me x squared equals -3. So x equals plus or minus the square root of 3 times I, or I square roots of 3. Okay, so those are 2 of my 4. And then my real solutions are going to come from this factor. And again, I think of this in terms of square roots. X squared minus 16 equals 0. So that would give me x squared equals 16. And that gives me x equals plus or minus the square root of 16, which is just 4. Okay, and again, if we type this in, what we're going to see is kind of a similar parabola that's going to cross, you know, here and here. Okay, so if you don't know that you should have 4 solutions, you're going to think the answer, if you're just looking at the graph, is x equals plus or minus 4. But you got to remember those 2 imaginary solutions. Okay, leads us to number 4. All right, so you're going to be tempted when you see this one on the test because you're smart and you're good at math. You're going to say, oh, that's easy to solve. Let's just do x cubed equals 1. And so x equals the cube root of 1. So x equals 1, right? People who miss this question will have that work right there. And that is not all the way incorrect. Okay, I'll go ahead and show you that it's not. So if we graph the function x cubed minus 1, so x caret 3, take away 1. We see this, and it definitely has an x-intercept of 1, right? So x equals 1 is correct. But your knowledge should tell you that, oh, I need 3 solutions, right? So I must have 2 imaginary solutions. Okay, so this is where what I showed you at the beginning is the only way to come up with that. Okay, so you would have to use sum or difference of cubes here. Okay, so I'm going to go ahead and do that. Actually, later in the chapter, I'm going to show you something else you could do. But for now, you got to know that formula. Okay, so again, you got to recognize perfect cube minus perfect cube. Okay, that's a difference of cubes. All right, so my formula for difference of cubes, and again, you won't really know this without using the formula sheet at first, is going to be a minus b times a squared plus ab plus b squared. Okay, remember it's a lot like sum of cubes, except the minus and the plus sign are flipped. Okay, then we recognize a is x, b is 1, and then we just sub in. Okay, so my binomial would be x minus 1, which we already knew. That gives us x equals 1. And then x squared plus a times b, so that would be 1x. So plus x plus b squared, so that's plus 1 squared would just be 1. All right, so that one, you know you're not going to be able to solve it. Nothing multiplies to 1 and adds to 1. So from there, to get your complex solutions, right, we have the easy part already. We already knew this. X equals 1. Okay, and then to get your 2 complex solutions, I think the easiest way to go from there would be, you could do complete the square or quadratic formula. Most people tend to prefer the quadratic formula. So just real quick, x equals negative b, so negative 1 plus or minus square root of b squared, so 1 squared, I'm just going to write 1, minus 4 times a, which is 1, times c, which is 1, all over 2 times 1, so all that's over 2. All right, so 1 minus 4 is negative 3. So we have x equals negative 1 plus or minus the square root of negative 3. Let this screen catch up, all over 2. And so there's our complex number. So I'm going to write it up by our other solution. So that would be x equal negative 1 over 2. That's our real number part of our complex number, plus or minus the square root of 3 over 2 times I. Okay, so remember, if it's a complex number, you want to split it into 2 fractions versus leaving it as negative 1 plus or minus I square roots of 3 over 2. Okay? All right, and then I will do this last one. It's very similar to the one we just saw, so I'll try to go a little bit quicker. Okay, so we recognize we have a sum of cubes. So we're going to use the formula that starts with a plus b. Then you have a squared minus ab plus b squared, which should pop up here in a second, where a is the square root of that. So a is x, and b is the, sorry, I said the square root, the cube root of that. So a is x, and then the cube root of 8 tells us that b is equal to 2. Okay, then we just sub in. So we have x plus 2 times the quantity, x squared minus 2x plus 2 squared is 4. All right, so, you might try to factor that, but nothing's going to multiply to be 4 and add to be -2. So the easy part of this tells us that one of our solutions is x equals -2. And then this last part will give me my 2 complex solutions. I'll tell you what, since I did quadratic formula on the other one, I'll show this one with complete the square. So just imagine this set equal to 0, then we'd have x squared minus 2x equals -4. What completes the square? So that'd be half of -2 squared would be 1. So I'm going to add 1 to both sides. So that gives me x squared plus 2x plus 1, which is a perfect square trinomial, equals -3. Okay, so this is going to factor to x minus 1 squared. Equals -3. So now we can take the square root, which is going to give me x minus 1 equals plus or minus the square root of -3. And so simplify that, you get square root of 3 times I. So my final answer would be x equals 1 plus or minus I square roots of 3. So this would be my other 2 solutions, which we can't see on the graph. Okay, I'm going to leave 6, 7, and 8 for you to try. Remember, those are in the filled out notes. I'm sure you guys will have questions because this has a lot to it. Okay, but use that technology to help you. Use that graphing calculator, ask questions, and get this stuff figured out. Like I said, we'll have a kind of a review now that I've given you quite a bit of material, probably the next class. All right, you guys have a good one, and hope this helps. Thanks.